Okay. So we need to know if these are true statements, if A and B are greater than 0. And we know this one is going to work out. This one would be, let's just use 1 plus 2 for A and B. And 2, is that equal to 1 over 2 plus 2 over 2? So this is 3 over 2, and this would be 3 over 2. So it worked out. Yep. So now getting into radicals, what is it going to be? Well, it's going to be, we can rewrite that as the square root of 3 is equal to the square root of 1 plus the square root of 2. Now, for you to know that, because honestly, I don't know what the square root of 3 is. So let me look. Square root of 3 is 1.7320, blah, 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 blah. Well, what's the square root of 2? It is well, square root of 1 would be 1. Oops, square root of 1 would be 1 plus this would be 1.4 something. So no, that's going to be 2.4 blah 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 blah. Those are not actually true statements, are they? So if that's the case, then let's express square root of 50 minus the square root of 18 plus the square root of 8 in the simplest radical form and combine like terms. Okay. So hopefully y'all remember how to do this. We can break this down as to say 25 times 2. Well, square root of 25 is 5, so we're looking at 5 square roots of 2 minus, what about the square root of 18? What can we use for that? Well, we can use 9 times 2. So that would be minus 3 square roots of 2. And plus the square root of 8. We can break that down and say square root of 2 times is equal to 2. Now that we have all these are the square root of 2, we can just simply perform the operation. So 5 minus 3 is 2 plus 2 is 4 square roots of 2. And that's how we would leave that one. There we go. That goes there. And then we just bring like term. Okay. Page 2. So for page 2, we're looking at the square root of 1/4 plus the square root of 9/4 minus 25. Okay. Well, can we square root 1/4? Sure. So square root 9/4. Sure. That's just 3. Now, for 45, we would say this is equal to 9 times 5. So that would give us 3 square roots of 5. Oh, that should be minus. Now, the only thing I'm going to do right here is I'm going to combine these like terms here. So that's 4 over 2. So that's going to leave us 2 minus 3. Number 2, we're just going to use distributive property. We know we can do that. So that would give us since we are multiplying the numbers, all we have to do is do that. But now what's this? This would be 2 times 2 is 4, but we can do that. Square root of 4 is 2. We would just do that. This is 2 times 3 minus square root of 2 times 4. And that's what we get. All right, let's do number 3. Square root of 3/8. We don't like that, do we? Because neither one of those are perfect squares. So what do we want to do? Let's do this. Let's break this apart and say 3/8. Now I can do this one. This will leave me with square root of 3/, this is 4. 8 is 4 times 2, which is 2 square roots of 2. Okay, so now that we've done that, what can we do here? Well, what if so I probably might have done this a long way. So now if I can multiply the bottom by the square root of 2 and the top by the square root of 2, well, the square root of 2 times 2 square root of 2 is going to be 2, which will give me 4. And this would be the square root of 6. And that's how they're going to leave it. Now there's another way we could have done this. Okay, instead of doing all this on the bottom here, we could have said square root of 3 over the square root of 8 times 2 times 2. That would give me the square root of 6 over the square root of 16, which is the square root of 6 over 4. Yeah, a couple different ways you can do those. And I probably took a long route there. So anyway, let's do the cube root of 5/32. Well, that's the same thing. If we break it apart, we'd have 3, the cube root of 5 and cube root of 32. Now, let's take the same route as they did earlier. So here's why I erased it. Let's just go ahead and do this. Let's say times 2 times 2. That will give you 3 cube roots of 10 over 3 cube roots of 64. Now we would have 3 cube roots of 10 over, this right here is going to be 4 times 4 times 4. So that is equal to, and what we're doing here, you have to rationalize the denominator. You cannot be left with a radical in the denominator. So that's the whole purpose. Once we get the radical out of the denominator, we're fine. Okay, let's do number 5. It says, okay. Yeah, this one's goofy. All right, so let's go ahead. Let's divide by what can we do here? Okay, we're going to divide. We're going to break it apart. Let's break it apart and say the cube root of 8x cubed times cube root of 2x squared. Okay, because we've got to have 5 for our exponents. So we would add those to get 5. Now, this one, we can cube root, right? We can cube root that, and that becomes 2x, because 8, the cube of 8 is, or the cube root of 8 is 2. The cube root of x cubed is x, so there's our 2x. And then we're just going to have to leave that. I don't like that, but that's all. Sometimes that's just how the cookie crumbles. Okay. All right, what else we got here? And combine that term. All right, so here we go. Oh, I'm already seeing stuff that I should know. You should be able to be, you should be clicking right here. Okay. You should know these. Square root of 3 times square root of 3 squared. Squared, which is 3. If you square root is 3. Okay. So let's go ahead and just write that as 3. And then we're going to have plus. I know what the last is going to be square root of 2 squared. Whereas our last part's going to be plus 2. Squared is 2. Now we have to deal with the 2 middle terms, right? And we know that those 2 middle terms are the outer and the inner, and they're the same thing. So it's going to be plus 2 square roots of 3 times the square root of 2. If we can do that and say 2 square root of 6 plus 5 when we combine these two. Okay, so there's 5 plus 2 square root of 6. I'll DEA. Okay, now, even more beautiful than that is this problem right here. Hopefully you see in that difference of 2 squares. You have conjugates. We know that because this is a plus and this is a minus, and the 2 terms are the exact same in both binomials. Therefore, all we have to say is x squared minus a squared, which is 3 minus 2, which is 1. That's the type of stuff you should be able to check out. So real quick, same thing as numbers or exercise 6, number 6, where you have these two. It's this simple. Difference of 2 squares. 5 minus 3 is 2. 7 minus 2 is 5. Oh, that's not right. Back at it. Too big of a hurry. That's not square root of 7. That's 7 times 7, which is 49 minus 2, which is 47. Here, that's going to be 5 minus 4 is equal to 1. And we know that. All right, so let me just show you how I know that so quick. Because the square root of 5 squared, these cancel and leave me with 5 minus, here again, Square root and a square cancel and just leaves you with 5 and 3. Here, the 7 is not the square root, so we have 7 squared minus the square root of 2 squared. Get rid of those. 7 squared is 49 minus the 2. This remains when they cancel out. So we have the square root of 5 squared minus 2 squared. These cancel and leave you with 5 minus now 4, because we can do 2 squared is 4, so 5 minus 4, and that's your 1. Let's do that. All right, so it says right this in the simplest radical form, which means we've got to rationalize that denominator. We've got to get that out. One of the easiest ways to do that is just to multiply square root of 3. Do it to the bottom, we gotta do it to the top. Okay, so what is that going to leave us? So the top, do just distributive property, that's going to be 5 square roots of 3. Now we're going to have the square root of 3 times a negative 2 square roots of 3. Well, is that not going to be 2 square roots of 3 times the square root of 3? That would be 2 times 3. So that would be plus 6. Okay, so that's the top. Now what happens to the bottom? Well, this is going to be, I wonder if it would be better to do conjugates here. All right, let's just keep going. This would be 25. 25. 3. That's another negative 20 square root, so another negative 10 square root 3. And then we're going to have a negative 2 times 6, or times 3, which is going to be a negative 6. So I don't like that, because I'm still going to have that in the bottom. All right, let's go back. I don't like that. I should have done conjugates here. Let's do that. That's going to get rid of our so let's do that. Let's multiply, since we can do whatever we want to, right? As long as we do it to the top and to the bottom. Let's do that. So this now is going to be 5 square roots of 3. Well, I think I actually wrote a plus on that. Anyway, okay. And then we're going to have 2 times the square root of 3 squared. So that cancels and leaves us with 2 times 3. So we're going to have 5 square roots of 3 plus 6. I may have wrote that down anyway. Now, to do this bottom, we have conjugates. So I can do what? 5 squared is going to be 25. What's negative, or what's 2 times 2 square roots of 3 times 2 square roots of 3? It's going to be minus, because we're going to have a difference of 2 squares, right? Well, we got to have 4 as the square of 2. And then what's the square of the square root of 3? Well, that's going to be 3. Okay, we just multiplied that together, we would get those numbers. So then we would have 20 minus 12, which is equal to 13. So this would be over 13. Now and you can leave it like that. That's fine. There is going to work. So we could have done conjugates right here to get rid of our radicals. A bit. So since that's it, let's go. Yay! Hip hip hooray! So y'all pretty much watch this tonight, and then we'll do the homework tomorrow during class. There's quite a bit, and it's just tedious. You got to make sure we're doing it very carefully.